Welcome. Thank you for your participation in this session. So in this session, we will be covering the Nexus, water, energy, food Nexus, but probably from a slightly different perspective compared to the previous sessions of yesterday and the day before. We all know the importance of Nexus, and we all, as specialists, we all strive to place and to develop this framework of governance due to its advantages in making integration possible, integration between sectors, integration between specialists, integration between also departments in the government and states. But to make this happen, we need knowledge, we need science, we need evidence brought by science and research. And this will be the core focus of today's session. We gathered top speakers, stars again. So let me introduce them before to give the floor to them to start. So today we've got with us Dr. Maha Halalsha. She has a PhD in environmental engineering from Wageningen University. Currently, she is a associate researcher at the University of Jordan. She is focusing on wastewater treatment and reuse, with more than 20 years experience in coordinating different national and international projects in this regard. And she is also active member in many organizations, networks, like the Jordan Engineers Association. She worked in many internationally funded projects, like GIZ funded project from 2016-2018. She also participated in one of UMI projects, Rewater MENA project. And she is active member for the National Implementation Committee for the Integrated Wastewater Management in Jordan. She published a lot of publications, and today she will be focusing on sludge exploitation in agriculture. We've got with us also Professor Walid Al-Khoubi. He is a professor and head of agronomy program at Rice Research and Training Center in Egypt. He has more than 25 years experience in the field of agronomy research, developing new varieties, rice varieties. He also served with the private sector, big international company, Olam International, in Nigeria, developing rice production in Nigeria and working with a lot of growers, 9,000 Nigerian growers. And he also worked in USAID and GIZ funded projects in this regard. And we've got with us Sebastian. I don't have your family name here. Andreasen. Yeah, perfect. Andreasen Sebastian. So he's the co-founder and CCO and director of Simbrain, world's leading producer of state-of-the-art silicon carbide ceramic membranes for water and wastewater treatment, with over 15 years of experience in the ceramic clean tech industry. So he got a master degree in engineering from Aalborg University in Denmark, and he devoted his career afterward in developing silicon carbide filtration products for cleaning of water to tackle some of the world's most pressing water-related challenges. He is CCO, as I said, CCO and director of Simbrain, and he is responsible of driving the company growth and global expansion. So the plan for today, I forgot to introduce myself. So I'm Dr. Youssef Brouzine. I represent UMI, International Water Management Institute in the North Africa, Middle East region. So for today, so I will give the floor to my colleagues to speak, ideally 10 minutes. And then we will have chance to discuss Q&A session. So the first speaker will be Dr. Maha. Yes, please. Let me prepare your presentation. Okay.
It's there.
Okay. Please.
شكرا جزيلا. طبعا رح اعمل بما انه معظم الحضور بالعربي رح يكون التقديم بالعربي حتى لو انها السلايدات بالانجليزي، بس ان شاء الله بتكون الامور واضحه. الفكره طبعا هي العمل على موضوع الحمأة اللي هي رواسب اللي بتطلع من محطات التنقيه، ناتجة عن اهتمام خصوصا في الأردن فيما يتعلق بالحمأة، لأنها مشكلة كبيرة. أمس كان في جلسة نظمتها التعاون الألماني GIZ في الأردن، وهذا الشغل شغل أخذته الجامعة الأردنية لصالح المنظمة ولصالح وزارة المياه والري، لحتى نبحث إيش في خيارات للتعامل مع استخدامات الحمأة، خصوصا إنه استخدامها في الأردن إلى الآن غير مقبول من وزارة الزراعة. فعمالنا بنتفرج على طرق مختلفة كيف ممكن إن نعيد استخدامها، لأنه في النهاية هي مصدر. فالفكرة من الموضوع إنه انطلب منا تحديدا دراسة التحلل الحراري للحمأة لهدفين. الهدف الأولاني إنه إشي بيسموه كاربون سيكوستريشن، أوصل لكربون ستيبل كتير ثابت لما بينحط في التربة، ما رح يصير عليه أي خلينا نحكي مزيد من التحلل. والهدف الثاني إنه هل بنقدر نوصل لنظام بيقدر يغطي حاله من حيث الطاقة من غير ما نحتاج، بحيث إنه نقلل تكاليف التشغيلية للنظام. وين مش عارفة كيف هذه أنية اللي بتقدر. أوكي شكرا. بس أول شغلة رح للناس يلي مش من القطاع ممكن بس أوضح شو المقصود بالتحلل الحراري، كيف عماله بيصير، بعدين مباشرة التجربة يلي عملناها مع النتائج الأساسية، وبعدين إيش النتيجة لهذا الحكي. مش عارفة أنا وين بدي أشهر. ممكن وحتى بقدر اضل واقفه، الا انه ما في يعني، وانا صوتي عالي مو مشكله، وانا بحب اكون واقفه وانا اذا في مجال. تمام. السلايدز حكينا انه في النهايه الحمأة عباره عن مواد عضويه، نيتروجين، فوسفورس، هيك على الاقل احنا كمهندسين بنشوفها. ايش فيها؟ هي في النهايه ريسورس، ولا ممكن يكون فيها بعض المخاطر المتعلقه ببعض العناصر، مثلا وجود ملوثات ميكروبيولوجيه، الباثوجينز ممكن يكونوا عاليين، لكن هذا الاصل انه احنا بنقدر نتعامل معه. ولهذا السبب كانت فكره التعامل مع التحلل الحراري للحمأة. المقصود بالبايروليسيس او التحلل الحراري للحمأة ان نرفع درجه الحراره، ممكن تكون بنبلش مثلا من 250 حتى ل 950. هذا كليته يعتبر تحلل حراري من غير وجود الاكسجين. هاي التريب اللي بيصير انه بيصير تحطيم للعناصر او خلينا نقول المركبات الكيماويه، تحلل حراري من غير وجود اكسجين. بينتج عن هذا الحكي عاده حسب كيف انا بشغل، بينتج اويل، زيوت، بينتج غاز، بينتج الشيء اللي بنسميه بايوتشار، اللي هو المنتج النهائي اللي احنا كان مطلوب منا ان ندور على نوعيته وهل هي تتماشى مع التنظيمات الدوليه، خلينا نحكي الستاندردز الدوليه. فهو تحلل حراري كراكنج، عباره عن تحطيم فقط من غير وجود اكسجين، هذا لازم يكون واضح. بالعموم بنقسمهم لنوعين بالعموم، في كثير انواع لكن خلينا نحكي شغلتين. في شيء بيسموه تحلل حراري سريع، نرفع درجه الحراره بسرعه كثير. بهاي لاحظنا انه لما نرفع درجه الحراره بسرعه كثير، الناتج الرئيسي اللي بيكون هو الاويل، الزيوت ماشي، والغاز هي اكثر من البايوتشار. بالسلو بايروليسيس او التحلل الحراري البطيء نرفع درجه الحراره شوي شوي للدرجه المطلوبه اللي بدنا ندرسها او بدنا نوصل لها. وهذا عموما البايوتشار اللي هو الجزء السوليد هو يلي بيكون المين كومبوننت. فاحنا كانت تجربتنا مركزه على السلو بايروليسيس، انه برفع الحراره شوي شوي حتى اوصل لدرجه حراره معينه، وكان المطلوب منا ندرس حرارات مختلفة. هي التجربة خلينا نقول بالنسبة للسلاج وعلى السكيل اللي اشتغلناه هي تجربة لدعم وزارة المياه والري عشان نوصل لأحسن درجات حرارة ممكن إن نشغل عليها، بالإضافة لقديش فترة المكوث كمان. عادة لما بنحكي على التحلل الحراري بنتفرج على أكثر من شغلة. لما بينطلب منا ندرس العوامل التي تؤثر على العملية ندرس أكثر من شغلة. الشغلة الأولانية وهي المين درجة الحرارة اللي بدي أعمل عليها التحلل الحراري. الشغلة الثانية قديش بدي أقعد السلاج جوات السيستم تبعي حتى أوصل للمنتج النهائي. هل بحتاج ساعة، نص ساعة، دقائق، قديش بحتاج. الهيتنج ريت قديش بسرعة برفع الحرارة، قديش درجة حرارة لكل دقيقة حتى أوصل لدرجة الحرارة المطلوبة اللي بعدها ببلش أعد قديش بدي أقعد السلاج جوات السيستم تبعي. والشغلة المهمة كمان إنه طبعاً التحلل الحراري ليس حكراً على السلاج. يوجد العديد من الفيد اللي ممكن إن ندخله مثل مثلاً مخلفات النباتات أو الزراعية، المخلفات الأبقار، شو ما بخطر ببالك في مواد عضوية ممكن إن نقوم بنفس العملية، لكن كل واحدة إلها خلينا نقول تعظيم للعملية مختلف بناء على دراسات العوامل المختلفة التي تؤثر على العملية. فإحنا بناء على اللي حكيته حتى أحدد أنا كيف بدي أشغل، كثير مهم أعرف ما هو الهدف من التشغيل. هل هو فور لاستخدامات زراعية المنتج النهائي اللي بدي أوصل له، أم أنا عمالي بعظم العملية أو بدرس العوامل عشان أوصل لزيوت أستخدمها مثلا للطاقة أو التنين كلاهما مثلا. لكن كل وحدة إلها process conditions لازم ناخذها بعين الاعتبار اللي بنوصل فيها للمطلوب. هلا المطلوب من عندنا احنا كان هو التعظيم بهدف الاستخدام الزراعي لزياده تقبل الناس والمجتمع للاستخدامات الزراعيه للحمأة بعد ان يتم معالجتها على درجات حراره عاليه جدا. طبعا من الشغلات اللي كمان مهمه يلي بنوصلها وكانت مطلوبه منا ان نوصل لكربون ثابت. الكربون الثابت بتعرفوا بسموها الانترناشونال بايوتشار انيشيتيف، هي زي مجموعه طلعت ما هي البارامترز اللي لازم تكون موجوده في الحمأة بحيث اني اعتبر انها هي ثابته في الطبيعه. ثابته في الطبيعه يعني لو حطيت الكربون في الطبيعه من هون لاقل شيء 100 سنه حتى يبلش يصير له تحلل اضافي. التحلل كتير بطيء حتى تبلش تلمسه بدك 100 سنه وقد تصل الى 1000 سنه. وحتى نوصل لهذا الحكي الريكومنديشن تبعهم انه اوصل لهيدروجين على كربون ريشيو 0.7. اقل من هذه ال 0.7 انا بكون متاكده انه انا الكربون اللي عندي ثابت في الانفايرمنت ما راح ياثر عليها سلبا. فكان هذا هو الهدف، اشوف خصائصه للزراعه بلس اوصل ل اتش على سي اقل من 0.7. فالهدف الاولاني خليني احكي لكم بس عموما من الادبيات ما هي الفوائد المرجوه من استخدامات البايوتشار في الزراعه. الهدف الاولاني يستخدم لتحسين خصائص التربه من حيث الاستراكشر، خصوصا في التراب اللي هي ضعيفه في الماده العضويه. لما بتحط ماده عضويه عليها بتتاثر ايجابا، بحيث انك لما بتسقي تستخدمها لاهداف الزراعه قدره التربه على المحافظه على المي وما تخسرها تهرب للمياه الجوفيه او يصير لها ليتشنج بتقل. شكرا جزيلا. الشغله الثانيه اللي خاصه بالزراعه انه يستخدم ايضا كمصدر للنيتروجين والفوسفور، لانه يحتوي على كميات من النيتروجين والفوسفور، وهذا هلا راح افرجيه. من الشغلات اللي كثير ممتعه وانا عمالي بقرا عن فوائده ولكنها بحاجه الى مزيد من البحث، انه هو بيثبت الهيفي ميتالز. بمعنى حتى لو كان في هيفي ميتالز سواء كان بالتربه او في نفسه، الموبيليتي تبعت الهيفي ميتالز تحركها في التربه رح يكون كثير بطيء وفي بعض العناصر بتعمل كومبليت immobilization، يعني بتوقف انتقالها في التربه وحركتها، بحاجه لمزيد من الدراسات، لكن هذه في عليها مجموعه من المنشورات. الشغله الثانيه المهمه انه هو البايوتشار اللي عماله بيطلع البي اتش تبعيته عاليه. في بعض التراب اذا كانت البي اتش تبعتها واطيه فهو بيساعد اني اوصل تو نيوتراليز البي اتش تبع التربه، وبالتالي بيحسن من خصائصها. الشغله الثانيه لما بنحكي عن درجات حراره عاليه ما في باثوجنز ابدا، خلص قتلناها، يعني ما راح يكون حتى لو حطينا ماء، حتى لو رجعت مي مره ثانيه هي عمليا ماتت، قضينا عليها تماما. وبالاضافه الى انه الكميات اللي بدي اتعامل معها في النهايه، لانه بيصير في تقليل من الكميه، يعني لو دخلت مثلا 100% سلادج على السيستم تبعي بطلع 50% تقريبا حسب طريقه التشغيل، 50% تقليل لكميه الحرق الناتجه، او خلينا نحكي المنتج النهائي، ما بدي احكي هاي حكيناها النقطه ما رح احكي فيها. الشغله الشغله اللي بدي احكيها هلا، احنا في الجامعه اللي كان مطلوب منا انه نشتغل تقريبا على 15 كيلو جرام من السلاج لكل باتش، وكان المطلوب منا انه نشغل النظام بباتشات فقط لدراسه موضوع تاثيرات درجه الحراره وفتره المكوث على خصائص الحمأة المنتجه. جربنا عده درجات حراره، بدانا ب 500، جربنا 500 600 750 850، وجربنا 3 فترات مكوث، ساعة ساعتين وثلاث ساعات، تمام؟ فهذه بس فقط علشان افرجي هاي السيت اب، فقط عشان بفرجي ايش الباتشات اللي اشتغلناها، كل وحده بتفرجي درجة الحرارة مع فترة المكوث، اوكي؟ فيعني عملنا تقريبا 12 تجربة ورا بعض، كل وحدة بكونديشن معين، وقسنا لهدول التأثير على شغلتين: كميات الناتجة من السلاج والأويل والغاز، بالإضافة لذلك الهيدروجين على الكربون ريشيو، لأنها بدنا إياها تكون أقل من 0.7. تمام؟ هاي فقط بدي أعرض على الفيد اللي دخلناه السلاج نفسه، قديش فيه كان مويستشر. طبعا في البدايه نشفناه، السلاج كان تقريبا 60% المويستشر كونتنت تبعه من 50 ل 60%، نشفناه نزلنا طلعنا السوليدز كونتنت ل 95%. الكربون فيه زي ما انتم شايفين نسبيا مرتفع 36%، الهيدروجين 5%، النيتروجين 7%، واللي هي تعتبر عالية جدا. هلا بفرجيكم كمان مقارنة حتى في المخصبات الزراعية يلي من أصل عضوي قديش مطلوب فيها حسب على الأقل التعليمات اللي هي صادرة من وزارة الزراعة. الهيدروجين على الكربون ريشيو زي ما انتم شايفين عالية 1.8، هدفنا ننزلها لأقل من 0.7. القيمة الحرارية 14.4 ميجا جول لكل كيلو جرام، وهذه تقريبا في المعدل، خلينا نحكي أعلى من المعدل شوي للحمأة اللي موجودة بكل العالم اللي ممكن نطلعها. الصورة اللي تحت بس بدي أفرجيكم كيف قديش المويستشر كونتنت تفرق على الكميات. اللي على الشمال اللي محطوطة بالفرن هذه اللي هي هون، هذه قبل ما يتم تجفيفها على درجة حرارة 105 درجة تماما. هاي تقريبا فيها المويستشر كونتنت بين 50 ل 60%. هاي بعد ما نشفناها، شوفوا قديش الكمية بتقل بعد التنشيف، على فقط بالتنشيف، ما حكينا لسه بايروليسيس ولا تغيير خصائص. خليني اجي، هدول فقط فيجرز بيفرجوا العلاقة، بس بدي اوصل للمين مسج. تفرجوا على العمودي هو الناتج النهائي از اويل، والعمودي هون هو قديش الناتج بايوتشار از ييلد. يعني دخلت 100% سلاج، قديش طلعت منه برسنتج بايوتشار، قديش طلعت منه برسنتج بايو اويل. واذا بتتفرجوا على المفتاح فوق الليجند، على الساعه الازرق ساعتين برتقالي، والسكني اللي هو ال3 ساعات. اللي بدي احكيه مش لا يعني طبعا درجه الحراره عامل كثير اساسي في تقليل كميه السلاج. كل ما بزيد درجة الحرارة كمية السلج الناتجة أو خليني أحكي الإند برودكت الناتجة أقل. الأويل بياخذ نفس الترند على الغاز بيزيد، الأويل بيقل. لكن خليني أوصل بس للمين مسج إنه البايوتشار ييلد اللي طلع المنتج النهائي كان تقريبا بين نزل ل 48%، وعشان يضل الرقم عالي براسكم يعني خلينا نقول بنزل للنص إذا بشغل على درجات حرارة مرتفعة بتوصل ل 850 درجة. أوكي؟ يعني تقريبا تقدر توصل لنصه إذا رفع درجة الحرارة ل 750. التأثير الرئيسي في العملية هو لدرجة الحرارة وليس للريتنشن تايم، ليس لفترة المكوث. درجة الحرارة هي العامل الأساسي اللي بيأثر، ما في داعي نروح لريتنشن تايم كثير عالي. بالنسبة للبايو أويل على ساعة واحدة ما كان في تأثير واضح لليل، على ساعتين وثلاث ساعات بلشنا نشوف التأثير. الهدف الرئيسي خلينا نضل مركزين على البايوتشار انه بيقل للنص تقريبا. بالنسبه للهيدروجين للكربون ريشيو زي ما انتم شايفين حصلنا على 750 اتش على سي تقريبا 0.5 5.57 اقل من 0.7 اللي مطلوبه اللي هدفنا نوصلها واللي هو كربون ثابت في الطبيعه. اوكي؟ فقررنا بناء على هيك انه نثبت او لما نيجي بدنا نعمل توصيات نقول اذا بدنا نشتغل على عمليه سيف بدنا ناخذ اي سلج موجود، لانه هذا السلج كان مصدره وحده من محطات التنقيه، بس عشان نضل بالسيف سايد اخذنا من حكينا خلينا نضلنا على 750 درجه. 750 درجه بتاكد انك بتنزل عن 0.7 وبعدها هذا السلج بيسمح له بقيه الخصائص فيما يتعلق بالهيفي ميتالز وبقيه العناصر. اللي بس بدي أأكده كمان لأنه بهمنا إذا بنحكي عن استخدامات زراعية تتفرجوا على 750 ساعتين، لأنه قررنا بالأخير نمشي من النتائج على 750 ساعتين. بضل النيتروجين كونتنت تقريبا 4.5% واللي هي تعتبر رقم ممتاز مقارنة حتى بمواصفات المخصبات الزراعية من مصدر عضوي حسب توصيات أو تعليمات وزارة الزراعة. علشان الوقت بس بدي امر عن هذه لانه مش هون المين مسج. النقطة الثانية المهمة انه بدنا نشوف هل هو هذا النظام بيقدر يغطي حاله فيما يتعلق بالطاقة ولا ما بيقدر يغطي حاله. البايوتشار الناتج اسمه له القيمة الحرارية كانت تقريبا 12.5 ميجا جول لكل كيلوغرام. الموجود بالادبيات واللي ماخوذ من مصادر مختلفة تقريبا يتراوح بين 8.5 و 17، فرقمنا كان تقريبا ضمن الرينج، وبالتالي هاي هي القيمة الحرارية للبايوتشار الناتج. بالإضافة إلى إنه البايو أويل قيمته الحرارية أيضا عالية ومرتفعة 32.7 خلينا نقول 33 ميجا جول بير كيلو جرام. إذا بنجمعهم الاثنين هدول تقريبا بيعطوني المفروض اني كنت عامله البالانس بجوز بسلايد بعدين، بس لما حسبنا قديش نستهلك طاقه للعمليه وقديش بقدر اطلع طاقه من البايوتشار والبايو اويل. البايو اويل لحاله بيقدر يغطي الاوبريشن كامل للمحطه من غير احتياجات لطاقه خارجيه اذا كانت المويستشر كونتنت تبع المدخل بحدود 50 بين 50 ل 60%، لكن هذا مش دائما الواقع. لكن خلينا نقول اذا كنت عندك سلاج تقريبا جاف نتيجه اشعه الشمس انت بتقدر تحصل سيستم شغال يغطي حاله من حيث الطاقه. بالنسبه للعناصر الثانيه اللي حكيت عنها البي اتش بيرتفع من العمليه نتيجه تحطيم الاسيد جروبس يلي بالمركبات الكيماويه تطلع. البي اتش ممكن انها توصل ل 8.33 بهاي التجربه، في بعض السلاج الثاني ممكن توصل ل 12 و13. فيعني لكن في بعض الادبيات بتقول انه حتى لما نحطه بالتربه مع الوقت برجع مع الخلط مع التربه بترجع البي اتش السويل بتقدر تاخذ ترجع للبي اتش تبعها النيوترال. ما تسالوني ايش الميكانيزم شو اللي عماله بيصير، لكن هاي اوبزرفيشن سو فار. عشان نعرف تاثيره على الزراعه بنحتاج لوقت اطول. الشغله الثانيه الملوحه، لانها هي شيء كثير مهم بالنسبه لتربنا. بالنسبه للسلاج اللي جبناه من هاي المحطه كان الملوحه فيه نزلت بالمنتج النهائي ل 640 خلينا نقول مايكرو سيمنز بير سنتيمتر، مقارنه بالداخل كان 2000، لكن بعض المحطات الثانيه لما عملنا لهم البايروليسيس طلعوا، فيعني لوكس انها هي كمان لها دخل بالمحطه وطبيعه السلاج الموجود. لما يكون باستخدامات البوليمرز، في بعض المحطات عندنا بالشمال بيستعملوا البوليمرز عشان يقللوا كميه المي، هذا بيخليه يرفع السالينيتي كثير، فهذا ممكن انه يكون كونسيرن لازم نكون فاهمينه. لكن المسج من هون انه الاستخدامات في الزراعه للبايوتشار بحاجه خلينا نقول لونج تيرم اكسبيرمنتس، بدنا على فترات على مده سنوات حتى نعرف تاثيراته الزراعيه. انا بخلص. الهيفي ميتالز اللي انتم شايفينه هون، في عمود بيفرجي قديش موجود بالفيل هيفي ميتالز للعناصر اللي قسناها. العمود الثاني بيفرجي قديش في بالبايوتشار اللي طلعناه مقارنه بتعليمات وزاره الزراعه للمخصبات العضويه، ومقارنه ايضا بالانترناشونال بايوتشار انيشيتيف اللي هي حاطه البارامترز كاملين. مقارنه بالانترناشونال بايوتشار انيشيتيف احنا within الرينج لكافه العناصر بالنسبه للبايوتشار. بالنسبه لمقارنه بوزاره الزراعه وتعليماتها تجاوزنا بالسيلينيوم، لكن السيلينيوم اذا بنتفرج على التراب في الاردن، لانه كان مهم انه نفهم ليش السيلينيوم ممكن يكون شوي عالي في السلاج. في التراب في العالم معدله في العالم تقريبا 0.4 ملي جرام بر كيلو جرام، في ترابنا ممكن انه يوصل في سنترال جوردن ل 17.5 ملي جرام بر كيلو جرام، فهو اوريدي بالتربه موجود، وهذا هو سبب وجوده ايضا في السلاج وطلع معنا في البايوتشار. طبعا ازالته ممكن نفكر بالابزوربشن من نفس البايوتشار الطالع، لانه البايوتشار الطالع السيرفيس اريا تبعته عاليه وممكن يستخدم از ابزوربنت، يعني له استخدامات مختلفه. خليني اجي على النيوترينتس وبعدين الكونكلوجنز مباشره. التوتال ان زي ما انتم شايفين ستيل عاليه على حدود ال 4% 5%، واللي هو فيري فاين. بالتالي محطوط اذا بتتفرجوا تحت البايوتشار التوتال ان التوتال فوسفورس والبوتاسيوم. التوتال فوسفورس 3.2، بينما بالمواصفه الاردنيه انت بتحتاج 0.9% B2 or 3، فاحنا وي ار ستيل فاين بالنسبه للفوسفورس مش ستيل فاين، يعني هو ريتش بالفوسفورس والنيتروجين حتى مقارنه بالمسميات العلويه نقص العضوي. هاي الانرجي بالانس اللي حكيت عنها كان لازم حطيت السلايد فوق، لكن فقط تو شو انه قديش الريكوايرمنت بالعمودين اللي على الشمال هون، قديش بنحتاج للسلاج دراينج عشان انشف السلاج، وقديش بحتاج للبروسيس نفسها. ان توتال بنحتاج 2570 تقريبا ميجا جول لكل كيلو جرام. هاي ميجا عفوا ميجا جول لكل كيلو جرام نحكي عنها. والريكوايرمنت التوتال عفوا اللي بروديوست من البايوتشار والاويل بيغطوا الاحتياجات بالنسبه للطاقه للتشغيل بلس الدراينج. اوكي، بروفايدد ذات تبلش بتقريبا 50%، اذا اقل ممكن نصير شوي كريتيكال تحتاج لطاقه اضافيه. كنتيجه مباشره انه بنقدر على 750 لمده ساعتين نحصل بايوتشار ستيبل في الطبيعه في اتش على سي ريشيو اقل من 0.7 وهي المطلوبه. تقريبا بنقلل من نسبه بكميه السلاج 50%، بحيث انه نطلع بايوتشار 50% من الفيد. الناتج النهائي غني جدا بالمخصبات نيتروجين فوسفورس والبوتاسيوم. الهيفي ميتالز بالرينج تبع الانترناشونال بايوتشار انيشيتيف، لكن في بعض العناصر وخصوصا السيلينيوم اعلى من الانستراكشنز اللي طالعه من وزاره الزراعه. might be potential كثير انه يكون energy self sufficient. بس الله يعطيكم.
وانت دكتور. شكرا.
شكرا دكتور على العرض. عرض قيم ومهم كتير. طرقتي لحاجات كثيره صراحه. impressive الله يعطيكم الصحه. So I will not take much time to wrap up because we need anyway we need time. But I will switch it to English. But I took note of your efforts to understand first the process that is needed to develop biochar from sludge, temperature, and also duration of the process, and also the energy aspect of this process, which is very important to capture the Nexus, again, the Nexus framework, and mainly the limitation of this solution, because each solution has limitations. So the selenium thing is very interesting. Limitations that need to be managed and investigated further. Thank you very much. I'm sure that there will be a lot of questions later on. But now we will go to the second presentation, Dr. Walid. So he will cover their experience with rice and water management. Okay, I think it's already here. Which one? This one?
Assalamu alaikum. It's a great pleasure to be with you today. It's a great pleasure to be with you today to share some of our experience during this great event. My name is Walid Al-Qobbi. I'm working as a professor and head research, Agriculture Research Center, Field Crop Research Institute, Rice Research and Training Center. My topics is sustainable intensification of rice production in the MENA region and the world. We are, it is a strategic opportunity for Egypt, MENA region, and the world rice production in reduce methane emission while saving water, creating climate change, and other benefits. Actually, rice crop considered one of the most important crops in Egypt. However, we consume a big quantity of rice. Egyptian consumer daily use, they consume rice. And rice crop play a big role in Egyptian economy. We have self-sufficiency of rice in Egypt, and in addition to we export the remaining quantity to some Gulf countries. Egypt, the problem as rice crop consumes some of water irrigation, and our focus here on how to save water. Rice usually cultivate in the summer season. We have two seasons in Egypt. One in the winter season, which may be wheat crop, and other crops such as forage, and in the summer it coming rice crop. Where rice area in Egypt, usually it is located in the northern area in Egypt, along with the Mediterranean. We have almost 10 governorate cultivating rice in Egypt. And we have a limitation to allow the farmers to cultivate rice in a south area. I'm coming from one of the most important center in the Middle East working for rice crop. It's called Rice Research and Training Center. We do research in addition to training for some African countries, in addition to some of our Gulf countries from Iraq and other countries. Our center located in Kafr Sheikh Governorate. It's almost 130 kilometers from Cairo City. Also, we have 5 components in my center. The first component is breeding program, which they are interested in releasing a new variety. And the second one is agronomy program, which is headed by myself. And we are interested in making a package for the new released variety. And third one, called plant protection program. Fortunately, it's headed by my wife. They are interested in disease, insect, and weed control. And fourth one is seed program, seed production program. And the fifth one is technology transfer program, which is interested to transfer the new technology to our farmers. Fortunately, we have almost 16 rice variety as a commercial variety. It is distributed in a different governorate in Egypt. We cover all our governorate as a breeder seed. And we are in a cooperation with the companies. We supply them the breeder seed, and they do multiplication under our supervision to produce more certified seed, which it's high quality seeds. Most of our variety is short duration variety, high yielding variety, and superior green quality, as well as resistant to disease and insects. Our vision to maximize yield and maximize the utilization of chemicals fertilizer by increasing fertilizer use efficiency and develop a drought, salinity, and heat tolerance variety we call mega variety or a smart variety. Number 4 is develop rice which is resistant to disease and insects. What our rice sector needs? Higher yield, lower cost, reduce water requirement, which is, as we are focused on, resistant to biotic and abiotic stress, less adverse condition, and improve grain quality. Actually, I'm working with a coalition. It's called the System of Rice Intensification. That organization. It's located in Oxford, England. And we are, as a coalition, working with rice crop around the world. We call SRI. The System of Rice Intensification is an agroecological management strategy based on sound scientific principle that enhance rice crop performance by providing the best condition for crop plant to express full genetic potential. Also, this system is we call a system of integrated rice crop management. It's just a system, not a technology, because it is flexible according to the area. This system has been initiated, established by this guy, this Frank Luliani. During his stay in Madagascar, when France was colonized Madagascar. And this guy has been died in 1995. if you look to this map, the only country which was applying this system is Madagascar, and after that, many people has been validated this system, including Egypt. This system has been introduced to Egypt by myself with the help of my friend or my close colleague, Dr. Norman Uphoff, is responsible for the system of rice intensification at Cornell University, USA. Of course, we have met together in Egypt and outside Egypt, and he is supporting for us to upscale this system, even in Egypt and outside Egypt. If you look to this map, in 2022, more than 64 countries around the world validating this system and applying. Unfortunately, it's a small scale, but we are scaling up and scaling out this system around the world. The advantage of the system of rice intensification to produce more rice, reduce pressure on water, reduce greenhouse gases, and lower costs. The main principle for this system is a young seedling which is very healthy and optimize the spacing in between plants, build up healthy, fertile soil, and reduce or applying the optimum amount of water. All this we can make sustainable agriculture, we call sustainable agriculture. And it can increase the organic matter in our soil to be used or to be used in the future crops. As I said, because we have more 2 seasons or maybe 3 crops a year. A part of this, we have this key study which has been done in last 2 years, and we already tested 2 varieties. One inbred and other one is hybrid. And we have observed that this system, which you call here, it is, we are comparing with continuous flooding. This is a convention method, and another one is SRI, which we say that saturation. We can observe that regarding water saving, this SRI has been saved almost 30% from irrigation water, and yield has been increased rather than the conventional method. The same thing with the inbred variety. We found that yield has been increased in addition to water saving more than 35%. SRI also can be used with another crops. We are using with wheat crop, sugarcane, and other crops can be used. We can apply this system. Of course, we have, with our coalition, we have a program, it's called wheat rice system. We cultivate wheat in the winter season and make or prepare the soil to be used for rice after wheat. Here I want to give the acknowledgement to the SRI 2030 coalition because they supported me and they gave me the chance to attend this very important event to pay the attention for everybody and to say and introduce this system and how it can save more water, especially we have a problem with water everywhere, water scarcity is a huge problem. Regarding to a rice crop, of course, if we are able to save more water, it can be used to another crops. This SRI 2030 is an initiative of the Homeland Conservation Trust based in Oxford, UK. SRI 2030 is a coalition whose mission to increase the adoption of the system of rice intensification, achieve 50 million hectares around the world to save more water. SRI is a climate smart set of practices for achieving rice that reduce methane emission, water saving more than 50%, and of course we can apply more benefits and blend it together. That's all what I want to say. Of course, we are training a lot of people around the world, and we are attending. We happy to cooperate with every place can save more water and can save our planet. Thank you.
Thank you. Thank you, Doctor. شكراً كثير. Thank you for sharing your experience. Very interesting experience. Where another example of Nexus, food, water, also climate change. I like mainly the paradigm that you are adopting here. There is intensification because we need food. We are striving for food security. So, but you are doing it in a sustainable way by saving water and also considering the climate change mitigation aspects. Looking forward to the questions to go into more details. Thank you very much. Now we go to our colleague Sebastian for his talk about their technology for clean water. Please, Sebastian.
Everybody. My name is Sebastian Andreasen, and I'm the co-founder of Centrum. Thank you for the organizers to allow me to speak today. It's a great pleasure being with you all. In my presentation today, I will continue on the same path as many others. The central theme of the conference is water scarcity. Water scarcity is, as many have said, is a global problem. It's something that affects billions of people. In addition to that, lack of access to safe water is also something that affects most people around the world, even in my country of Denmark, where we have plenty of water. There are many ways of mitigating this. It will take time. And in my presentation today, I will focus on how Sembrain, or how we work on mitigating water scarcity through our silicon carbide technology that allows us to increase capacity from existing water treatment infrastructure up to 5 times and provide safer drinking water quality through this process. So in order to make this case, I'll start by introducing myself, my company. I'll talk about how water is treated today and what's the current paradigm in water treatment, and lastly, how we address that with our technology. So who are we? We are a manufacturing company headquartered in Denmark, in Scandinavia. We have manufacturing facilities in Denmark and in Texas, US. And we provide our silicon carbide membrane filters for water treatment and for wastewater treatment all around the world. We have more than 500 commercial installations globally. Today we are owned by a German group called Ski and Water. Ski and Water is the investment arm of the majority owner of the car company BMW, and she is in particular very, very concerned about water scarcity. So she's investing a lot of the funds into companies' assets that can mitigate water scarcity, Sembrain being one of them. In our portfolio company, we are a group totaling a turnover of 2 billion euros. Just very quickly, our product is used in a wide range of applications within drinking water from various sources. We also treat wastewater for reuse, either for irrigation, even for portable reuse or for technical purposes. From municipal sources, MPR, and also in the industrial sector. Lastly, and this is going to be the main topic of my talk today, is how we rehabilitate sand filters. So going in and upgrading existing sand filter infrastructure and provide a lot of benefits through that process. So in order to do that, I'll start by explaining the current water paradigm, how water is treated today, which is mainly through sand filters. Sand filters has been used predominantly for the last hundreds of thousands of years. It's a great technology. The sand, the media itself, is globally available and will continue to be there. They're quite simple to use and operate, which is a big benefit. The way they work essentially is that you have layers of sand, and you then force water through these layers of sand, either by gravitation or by means of pressure. However, there are some challenges related to this technology. One of them is that you need to apply a lot of chemicals in order for them to function effectively. They take up a lot of space due to the extensive pre-treatment. In order to keep them clean, you need to use a lot of wastewater to wash the filter media. And lastly, in and of itself, it's not a disinfection, so it doesn't provide disinfected water directly. On the other hand, we manufacture a different type of sand filter. It's a structured filter. It's made out of silicon carbide, which is a sand-based media that is fused together with carbon in a permanent bond. We produce them into these plates, as you see on the picture on the upper left side. And these plates are porous. They have tiny holes around 0.1 micron. We put them into these module blocks, kind of like a Lego block. You can stack them on top of each other depending on the size of the plant in question. These are then submerged into the dirty water, and clean water is extracted on the other end. I'll show you the basic functionalities, how we use silicon carbide to form a plate, a porous plate, with almost 50% porosity, meaning 50% is mass, 50% is air. The selected layer is on the outside, around 0.1 micron in pore size, and it's operated from outside to in, so all the particles, bacteria, and solids are deposited on the membrane surface, and clean water then goes through the substrate body and out through these holes that you see in each end. Similar to a sand filter, you also need to clean them, and you can do that by reversing the flow and backwashing, as you see it's illustrated in the video. In each of these modules, we have 42 of these plates, comprising around 7 square meter membrane. So, on the lower left side, you see our conventional an old-style gravitational sand filter. Underneath the water, there is around 2.5 meters of different layers of sand medium, and gravitation of the water flows through the media, and relatively clean water comes out in the other end. In this particular site, you have around 42 square meters of filter area, and it means you have 42 square meters, maybe the size of this room, maybe a little bit bigger, that separates the dirty water from the clean water side. On the other hand, if you submerge, which we are doing here, our silicon carbide filter modules into the same tanks without any enlargement or any modification, you don't get 42 square meters of filter area, you get 2,200 square meters of filter area, separating the dirty and the clean water. And for that reason, we're able to increase capacity within this existing footprint up to 5 times, and at the same time provide higher efficiency with less waste and a better water quality in the end. So this is a very fast and affordable way of increasing capacity on existing water treatment infrastructure. On your right side, you see a typical filtration spectrum where you have bacteria, solids, Cryptosporidium, E. coli, and where they fit in the filtration spectrum. Our pores are 0.1 micron, and in comparison, a sand filter's pores between the media is from 10 to 200 microns. So it's not an absolute barrier for either bacteria or for particles. This also means that if you have a spike in the water quality, let's say it starts raining or other factors impact the incoming water, which results in it becoming more turbid. For a sand filter, that would mean that the filtering quality in the other end will also become more turbid. That's not the case with our silicon carbide filter membrane. This is from a site in St. Louis, US, where you see the incoming feed water turbidity marked by blue, and you can see the results on the left side. And on the right side, you have the fluid turbidity, which are the orange dots. And even though there are occasional spikes due to rain at this particular site, where the turbidity goes up very rapidly, it has zero impact on the outgoing water quality, and always remains below 0.1 NTU. So in order to mitigate that with a sand filter, you have to have a very extensive pre-treatment. You need to have screening, you need to have coagulation in very, very high concentration that also has a very negative impact on the surrounding environment, on the costs of treating the water. And secondly, you need large sedimentation tanks. You have all seen these round tanks that are near water treatment facilities, where you have to store the water for more than 2 hours to protect the subsequent filter media. If you were to, I talked about rehabilitating existing filters, but if you were to make a greenfield installation, you would not need the same amount of screening, coagulation, or even sedimentation if you're using silicon carbide filter. I'll talk to you about a specific case study. We've done upgrades of sand filters all around the world in larger and smaller scale. This is a case where it's a brackish water beach well, where the customer, in this case, installed sand filters before the RO, and he was not able to meet the RO quality, feed water quality requirements. meaning that they clogged up very quickly. So he had to do something differently, and his basic setup consisted of a ration tank, chemical dosage coagulation. He had lamella separator, followed by the sand filters. And even with this extensive process, he was not able to meet the RO feed water limits. Whereas when he converted to a silicon carbide filter, he installed the filters directly into the lamella separator using the existing infrastructure. And his SDI went from 5 to 6 and down to below 1, providing a safe RO feed water quality. In summary, if you pursue this path, if you pursue the path of upgrading existing sand filter infrastructure that is aging, you can achieve a lot of benefits that results in mitigation of water scarcity in the most affordable way. If you want to increase capacity, you can achieve up to 5 times more water output. You can achieve a quality that is safe for drinking in one step, and you can reduce the amount of coagulants or oxidants that you use before the filtration process. And finally, your base volume is reduced by 1/5, and your footprint is also in turn reduced significantly. With that, I'll conclude my talk, and if there are any questions, if you want to see the products, we have a booth at number 42. Thank you.
Thank you, Sebastian. Very interesting presentation, very interesting innovation. Another role of private sector innovation, not only participating in finance, etc. So private sector can drive innovation and provide a solution, science-based solution, and filters are a very, very strategic key component of in the non-conventional water industry. I'm sure that there will be a lot of questions. So yeah, and this will be the next part. So let's go to Q&A session, please. If you got any questions or remarks, please let me know. I will. Thank you. So I will collect first round of questions, and we can be back again if there are more questions. So we've got Dr. Ahmed, you, and Dr. Four questions, please. Introduce yourself and then your question.
Thanks, Dr. Yusuf. My name is Ahmed Nasrallah. I am a aquaculturist and I work as a country director for Fish in Egypt. This is one of the best sessions I have attended. I enjoyed it very much. And my question to Dr. Amha is usually in compost processing, we talk about CN ratio. Here you talk about CH ratio. What is the difference? Why you go from CH not to CN? My question also to Dr. Walid about efficiency of water use in rice production. How much percentage your system achieved in terms of water use? Just as a percentage, this is quite interesting. In our country, saving water is very important. Sebastian, I enjoyed your presentation. I would love to have some time to discuss. As in aquaculture, water treatment and recycling is quite important. I saw your presentation, quite interesting, but I didn't hear capacity. You talk about size, but you didn't talk about capacity meter per hour per day. Thanks.
Thank you. Thank you, Dr. Ahmed. Mr. Hisham.
Thank you. Hisham Sherek from FAO. I have a question for Mr. Walid. This approach, SRI approach, is very interesting. And I know also that rice is a very important crop in Egypt, very strategic for food security and very demanded food. But at the same time, Egypt is facing water scarce, let's say, increasing water scarce situation. And with the approach you have presented, we see that crop water requirements are decreasing, and this is a good result. But at the strategic level, do you think that maintaining rice production with the existing techniques, with the existing way to produce would be strategic for Egypt, knowing that the trend of water scarcity will be more and more increasing? So this is kind of strategic thinking about rice production. My second question is for Ms. Maha. I'm not a soil expert, but I see that in your presentation you stressed on the biophysical advantages of use of sludge. Now the idea is, if we want to design kind of guidelines for countries on the safe use of sludge, what could be let's say, the steps, the recommendations, the lessons learned from your expertise, not only on the biophysical side, but also on the socio-economic, maybe on the political side as well? What kind of, let's say, approach countries should follow to design ad hoc guidelines that could be implemented, not only at the strategic level, but also on the field level to use this sludge safely? So,
Shukran. Thank you, Sishan. Engineer Anwar?
Thank you for all the presenters. My first question is to Dr. Walid.
Could you present yourself? Could you introduce yourself first, so everyone?
Sorry. Anwar Adwan from Jordan Valley. My first question is for Dr. Walid. Does the rice cultivation in Egypt affected by the saline water? And if yes, we see that the majority area is in the north. And through our visit to Egypt, many times we also realized that there is a problem from the saline seawater that's passed through to the cultivated area. So does it affect also the rice cultivation and production? This is question one. Question two is to Sebastian for the filtration system. In the Jordan Valley, we have some farmers who have saline wells, and I saw them that they implement a sand filter before the RO plant. So does this device or filtration system will be efficient from the normal sand filter that they are using now? And what about the cost? Is it in the hand of the farmers that they can implement it? Thank you.
Thank you. Thank you, Engineer Anwar. And fourth question here, Dr. Walid.
Frankly speaking, really, I enjoyed all the presentations. Dr. Maha, you did excellent work, analytical work, and convergence. You know, I like all your processes, but my main concern here, we can play, we can get really marvelous results, but the scale of the controls. This is very, very important. Tomorrow I can bring you an iceberg here for a people, but is it economical or not? It can really change the whole magnitude of your findings. This is what I would like to hear. But from technical engineering, I'm a water resource engineer. I like your approaches, fantastic, but I would like to hear more analytical, findings, and it will solidify your points. This is very, very important. Dr. Walid, I like your approach. Congratulations for what you are doing, transferring this knowledge really to Egypt. But as my colleagues said, I know that you have some intrusion to the delta, and with climate change, you will be having more and more water shortage, and Egypt now is suffering. And I know now there is aggressive plan, to utilize agricultural drainage water, which is highly saline, specifically in the delta. Now Egypt used to throw about 15 billion cubic meter to the Mediterranean to keep the salt intrusion away. But now they cannot manage to do that. So how it will affect your approaches, to
enhance the rice cultivation. But congratulations for this. Now for Mr. Sebastian. Now again, your technique really is very, very important. And I can see a big room, large room, very effective room, specifically in industrial wastewater treatment, can make a difference. But I would like to see more and more analysis on the economic side. Maybe I can discuss with you here. Thank you very much.
Thank you very much, Dr. Walid. So yeah, let's start by the first round of answers, and let's start with you, Dr. Ma.
With respect to the difference between CN and H over C ratios, the first one, CN, you know, it's like a biological convergent process with composting. So we depend mainly on the bacteria, and in this case, you really have to adjust the C to N because both are very critical to the bacterial action. However, with the pyrolysis, we are completely talking about different process. It's basically cracking of the organic material without any action of the bacteria. And in this case, we really want to see this cracking, the end product of the cracking process, indicated as H over C, which indicates the aromaticity of the end product and its stability. And that's why we focus mainly with cracking on H over C rather than C over N. It's completely different process. That's the point. For the second question, with respect to the reuse, I do appreciate your question for sure. It is, I would say, a challenge for the whole region. Until recently, we started to see some application of sludge into land for agricultural production. Still, we have many steps to go forward. Worldwide, it is very common practice to use it for agricultural production, depending on its quality. In Jordan, we are still having some difficulties with its reuse for agricultural production, even for land application. This effort is part of a bigger project that is funded by the GIZ. Yesterday, they have a session on that, sustainable sludge management, and they are now doing lots of efforts together with the agricultural ministry here in Jordan in order to change the regulations and to allow the use of sludge into agricultural land. It has for sure lots of advantages, and if we want to like have the trade-off, still the sludge reuse for agricultural production overweigh its disadvantages. So I think it is time to go forward. Social acceptance is still a challenge, and we still have to do lots of things on this regard. I'm sorry I don't have concrete answer. It is still a big issue and big debate in the whole region, and particularly here in Jordan. For the point on economy of scale, for sure I do agree. The only thing that I want to emphasize is that again, this is one component within a bigger framework of a project, bigger project. There will be a kind of scale up, though the treatment plant in which pyrolysis unit will be included is not a big plant, but stepwise we can come up with some calculations. I guess some feasibility studies already were done on this project, but I can also get you in contact with the coordinator of the project from the GIZ, and I'm sure she has an answer on the economy of scale.
You know, sorry. You know, we have hundreds of thousands of tons of sludge, and you know the cost of the transportation of sludge
for sure
place to be used as a heat source for cement factory, not agriculture.
صحيح.
Much more than the
صحيح.
food cost. So it's not.
صحيح.
So we have to really to investigate this deep.
I agree, definitely.
Thank you, Dr. Maha. Dr. Walid?
Okay, thank you. Regarding to Dr. Ahmed, the question for water use efficiency for our rice crop, usually in our strategy in my center, we focus on short duration variety which has stay for a short time and during the season. The old variety, it was taken long time, and it was consume so much quantity of water. By the moment we we releasing new variety which consume which stay short duration in during the season, and this reflect a big yield or higher yield using water. You know, water use efficiency, we calculate this. 1 cubic meter produce 1 kg of rice. So the old variety before 1 kg production of rice, it was consume 1.5 cubic meter. So our new variety, by the moment, it's reducing the huge amount of water. Regarding to Dr. Hisham, actually the system, it's good. It has been applied for a long time in Asia and Latin America, and newly has been introduced to Egypt. This thing is, we are trying to find out some solution to save our water, especially the rice crop. Before, it was accused as big consumer for water. But the problem, we are changing the mind of our farmers. How? Because to apply the adequate quantity for rice. Rice not consume huge water as before. We are trying to change the mind of our farmers, because just to apply the adequate quantity, not the excessive quantity as they were applying before. This system only we keep the water, the soil just saturate, and after it come down, we push water again and to keep it just saturate. This wetting and drying, it make aerobic condition, which it give the root system, it enhance the root system inside the soil. Also, it increase the activity of microorganisms, as well as it reflect on soil fertility. So by the end of the day, yield will be higher, and the water quantity, it should be saved. We use the saved quantities to be added for additional area or to be used for another crops. Regardless, we keep in mind that yield no touch. If the yield come down, of course, we will go away from this system. After we did our trials, we found that this system never decreased the yield. I hope that I could give you the answer you're asking. Sure, for our increased population in Egypt, we require to increase our yield more and more to cover and to keep our country in a self-sufficiency of rice. And you know that rice help us to reduce the stress on wheat importing from outside. Regarding Dr. Anwar, of course, we have area in Egypt, it's already affected by salinity. Usually, the Ministry of Agriculture, in a coordination with the Ministry of Irrigation, they allow us to cultivate some area. Because the Ministry of Irrigation, they supply the quota of water to be used in agriculture. So we cultivate rice in a northern delta, which already affected by, because it is close to the Mediterranean, it's already affected by salinity. But if you not cultivate rice in that area, of course, salinity will be accumulated to be there. Our strategy in my center too, we're reducing our variety, which is, each variety can be adapted for adequate area. because we have some variety, it's already, it has the ability to salinity tolerant, and it can grow well under such condition. Of course, we have another variety, it's already has a susceptible, it can be, it can't grow well under the area which already has a higher percentage of salinity. So we have diversity of our variety. We distribute all this variety and according the area which we have. That's one point. The second point is we have reuse some the water, especially in the area which located in the end of intervals. Of course, some people they can grow fish, and we reuse this water again in a water, and we push it into use in rice crop. So in that area, don't worry, we have the variety which able to grow under such condition. Regarding to Dr. Walid, I think your question is close to Dr. Anwar. In Egypt, you know that rice crop is occupied a large area in the summer season. Although we have a limitation to extend the area of the cultivated area of rice crop, but according our experience and my center in general, this center is one of the most important center. We have all of our stuff. We able to put the strategy which can help us and can help Egypt to save our areas from salinization and keep rice cultivation in Egypt. Of course, we have some variety. As I said, I think the same thing. We this year, and we already registered new variety which able to grow. It can use only half quantity of water and can grow under higher amount of salinity. Now it's close to 3,000 ppm.
You know, in Hassa we have Hassawi rice can survive 5,000 to 6,000. To come and visit.
I heard that, but actually this is a small area. If you go to a large scale as in Egypt, no, it's the situation is different.
We are talking about the variety, regardless of
that's good, but we of course I'm trying to connect some researcher in Saudi Arabia. The problem maybe I face.
In 10 seconds, please. 10 seconds.
Yeah, the quality, the rice, it's acceptable for Egyptian consumer or not? That's a problem.
You know, it's 1 kg, 50 Saudi riyals. It is, nutrient, very, very high in iron, and it is.
That's good, but
ladies when they give birth. It is like a gold in Saudi Arabia.
Shukran, doctors. Shukran, doctors. No, very interesting discussion. We will definitely keep talking afterwards. Definitely, shukran. Sebastian, please.
Does this work? Thank you for the questions. The first question was related to aquaculture and what are the capacities we operate within. Our biggest installation with our membrane is 140,000 cubic meter per day, but typically capacities ranges from 1 to 50,000 cubic meters per day. And our product is, by the way, also used in the aquaculture sector for intake water, for typically fish farming onshore. Then there were questions related to costing, which is a very important topic. I think one of the root causes of water scarcity is the cost of treating and distributing water. We have a lot of water in the world, but
the resources to treat and distribute is a different topic. We would not be in business if we were not competitive. And so obviously the jobs that we win, we are the price competitive option. In the case that I talked about today, where you go in and you rehabilitate and upgrade the existing infrastructure, if you were to do the same with a conventional membrane, it would cost around 3 times that cost. And if you were to expand the existing sand filters, it would be much more than that, since you would have to build the entire treatment process all over again. You mentioned industrial wastewater. This is also, I think, 30% of our market and what we do, primarily within food and beverage and pharma, oil and gas, and scrubber wastewater treatment. I would be happy to meet and talk more about that. Thank you.
Thank you, Sebastian, for 2 things, for the answers and taking few time to make it. Thank you. I appreciate it. Thank you very much. Unfortunately, we don't have time to take more questions. I invite you to reach out to our speakers. I will not wrap up because it needs time, but I think today we had a chance to participate in very scientific and innovation session about Nexus. So well done. Thank you to speakers. Thank you to you and to our assistants and translation team. Thank you very much.
Thank you. Likewise.
Number 42.